Okay, third press the charm. Alright, let's find the stop giggling. Let's find the flux of the vector field zk through the upper hemisphere of a sphere of radius 2, oriented at the origin, centered at the origin, oriented outward. Okay, good. Next.
Draw it.
Draw it. Good idea. Okay, so hemisphere, what's that?
Top half.
Top half? Okay, so there's half a sphere, kind of.
Yeah.
Centered at the origin, that's good, because our conversion thing that we just developed really only works when it's centered at the origin. Okay, so I'm centered at the origin. What's the radius?
2.
2. Okay, and what else? It's oriented outwards, right? So my vectors that I'm talking about are going to stick straight out. Does that agree or disagree with the D area I just developed?
That agrees.
That agrees with the D area I just developed? So I should recall my D area, which is what? Ooh.
Oh, the vector sine phi, cosine theta. Sine phi, sine theta, cosine phi. R squared, rho squared.
Wait, what's R?
2.
2. So 4 here, and then a
Sine phi.
sine phi, and then a D.
Phi and theta.
Perfect.
Yeah.
Okay, so I want to take my flux integral, which I don't have, so I'm going to write. All right, I want to integrate over the surface F dotted with the area. And now I'm going to put all that jazz in. So I'm going to get a double integral. And there's going to be some stuff, so I need to leave a little space. And then we're going to dot with this thing. So sine of phi cosine theta, sine phi sine theta, cosine phi. And then there's a 4 and a sine phi d theta d phi. Okay. What's the next thing? Good, I need to put the vector field in terms of the function. Wait, in terms of a function?
In terms of the system.
Good, so here I'm talking about a sphere, right? So I'm talking about thetas and phis.
How can we switch the thetas and phis?
Oh, the order?
Yeah.
I don't know, randomness.
Okay, it doesn't matter.
No, it doesn't matter. It'll matter in which bounds go where, but
Yeah.
yeah, it doesn't matter otherwise. So what's my vector field? It's Z.
0, 0, 0, 0.
So 0, 0, cosine phi,
Rho cosine phi.
rho cosine phi. So I need what?
2.
Yeah, I need a 2. Okay, and thankfully when I do this dot product, lots of things will go away. What else have I missed here?
Bounds.
Any bounds? What are the bounds on theta?
0 to 2 pi. 0 to 2 and 0 to 2.
0 to
0 to 2 pi.
2 pi on the thetas, all the way around. And then the phis are going
0 to pi over 2.
Negative pi over 2 to pi over 0.
0 to pi.
Just on the top half.
So remember, they just controlled the declination off the z, right? So they range from 0 to pi. The negative angles you get by doing more theta.
Maybe we only need.
So you could arrange this in 2 different ways, right? You could run the thetas from 0 to pi,
Oh, yeah.
and the phis from minus pi over 2 to pi over 2. Or you could run the thetas the usual way, 0 to 2 pi, and then you only need phis between 0 and pi over 2. I would really recommend towards 0 to pi over 2. Cool? Alright, so I get out of this the integral from 0 to pi over 2, the integral from 0 to 2 pi of what?
Or 2 cosine squared phi.
2 cosine squared phi times 4 sine phi d theta d phi. Okay, so some of that can come out. What all can come out?
Eight.
Okay, there's an 8. There's also a 2 pi right there. Right from the thetas. Because I don't have any thetas, right? So that sounds like I've got a 16 pi times what? Not so bad. The integral from 0 to pi over 2 of cosine squared phi sine phi d phi. So how do you solve this?
Two changes of 1 minus substitution.
U sub? Okay, so what do you let U be? Sine phi. And what do you get for du then?
What?
Cosine. Wait, why did we let u be sine?
Cosine is
No. How about let's let u be cosine,
the higher power.
the one that there's more of. And then du will be sine phi. D phi. And what did I screw up?
Yeah, you get negative.
Yeah, there's a negative in there. So that reads like I got negative 16 pi, the integral of,
0 to 0? No, 1 to 0?
hang on, let me put the thing in. So I get u squared du, right? Okay, now the bounds are when phi is 0, what's u? 1. And when phi is pi over 2, what's u? 0. Okay, so I got the integral from 1 to 0.
You just flip it, make it positive, -1.
Okay, so let's flip it and make it positive. So that'll give me,
Positive 16 pi from 0 to 1.
okay. So I'll get 16 pi, the integral from 0 to 1 of what? U squared du. So I get 16 pi u cubed over 3 evaluated from 0 to 1. Reads like 16 pi over 3. What does that tell you?
Flow through this section of the sphere.
Good. The flow through the top half of the sphere is positive, right? There's some net flux.
There's stuff on the out.
Yeah, that's stuff going out because I oriented the sphere outwards. Cool. You guys see that? So there is a tendency in this vector field for stuff to flow through that kind of net that I made with that hemisphere. Cool.